All right, we have a few topics to talk about today. We're going to start with cells in bone. The three types of bone cells we're going to talk about are osteoblasts, osteoclasts, and osteocytes. They all come from a stem cell, but we're talking about them after they've differentiated, okay? So osteocytes, they're the most abundant cells in bone. They're mature bone cells. They maintain our bone structure, they help to recycle some calcium salts, they assist in repairs, and they kind of get like buried beneath the layers of bone as bone continues to be formed. Osteoclasts are cleaners. They're gigantic, like 50 or more nuclei, like literally huge. They secrete acids and enzymes to help break down bone, and that helps to release calcium. So if you're low in calcium, osteoclasts are going to grab some of that calcium from your bones. So it helps to regulate calcium and phosphate concentrations in our fluids. And then we have osteoblasts. Now they're builders. Blasts are builders, clasts are cleaners. They produce new bone. So they lay down a bony matrix, and as they get buried beneath, they become osteocytes. And so they help to deposit calcium salts. And again, as they get buried beneath bone, they're going to become the osteocytes. So a bone that lays down new bone is osteoblast, the builder. A mature bone cell is an osteocyte. And a bone cell that breaks down bone is osteoclast, the cleaner. All right, now we're on to ossification. So our skeleton. Well, our skeleton determines the size and proportions of our body, and it begins about 6 weeks after fertilization. Now, that does not mean you have a fetus, an embryo has a fully formed skeleton at 6 weeks. It just starts then. And it ends around 25 when your clavicle and your facial bones finish ossifying. So ossification is that replacing of other tissues with bone. So what do we need for bone growth? Well, we need minerals, especially calcium and phosphate. During pregnancy, a person loses bone mass, literally from teeth and bones take it to build a fetal skeleton. Vitamin D is essential for us to absorb and utilize calcium. We need vitamins A and C, and hormones, growth hormones, thyroid hormones, and sex hormones all help to control bone growth. The remodeling of bone. Well, bone is continuously remodeled. The protein and mineral components are removed and replaced. In adults, the entire skeleton is replaced about every 10 years. Might be 7, but about 10 years, okay? So bone can adapt to new stress. So regular exercise is important. Heavily stressed bones become thicker and stronger. Bones without stress can become thin and brittle. So doing weight-bearing exercises, even if that just means walking, is excellent for bone health. So even after a few weeks on crutches, a bone can lose up to 1/3 of its mass, which makes you weaker upon returning, like if you are an athlete. So you have to be careful to do physical therapy and enough rehabilitation so that you don't re-injure yourself. In space, astronauts can lose 1 to 2% of their bone mineral density every month. So for short trips, that's not a problem. For longer trips, they try and make do as best they can. So bones are living tissue. Yes, absolutely. They grow, they repair. What are some vitamins and minerals needed for bone growth? Do you remember? Now we have calcium, phosphates, and the vitamins D, A, and C. So if you don't have enough, you can end up with something called osteoporosis, and bones are much weaker and fragile and subject to fracture. Now there are 2 types of ossification. So we have intramembranous ossification. And that literally means the bone develops from a fibrous membrane. So it forms the flat bones of your skull, your cranium, your mandible, and your clavicle. That's it, just a few little bones. So there's an ossification center where ossification first starts. So the stem cells lay down a template. The stem cells become osteoblasts, and now they turn that template into bone. So they start changing that extracellular matrix by depositing calcium. Okay, so they turn it into bone. So from this fibrous template, we get bone. So here's just a little sketch of what that would look like. Okay. Now, endochondral ossification is when we replace cartilage with bone. And that's how most of your bones are formed. So except for your cranium, your mandible, your clavicle, facial bones, right? So it's this, okay? So chondrocytes form a template, and that's cartilage, okay? So the matrix begins to calcify, the chondrocytes die, blood vessels come in, and then osteoblasts are going to start building the bone. They're going to build the center of the bone, the diaphysis first. So that's the primary ossification center. And then at the epiphysis, the ends, we get secondary ossification centers, and they're going to kind of come in, and from the middle, we're coming out. So what we end up is a thin line on each end called the epiphyseal plate, okay, or your growth plate. So the ends of the bone remain covered in cartilage, but remember I said how we're growing, starting at the middle and growing up, and starting at the ends and growing down. So we end up with a thin layer of cartilage. And that separates the epiphysis and the diaphysis. That's your growth plate or epiphyseal plate. Now, the growth rate, how quickly that cartilage plate is going to grow, is going to depend on hormones and all those other factors, okay? It becomes the epiphyseal line in adults, and then it's not, there's no more growth there. So the danger is if you get a fracture and it's on that epiphyseal line, doctors might be concerned because it could affect the growth in length of your bone. So which type of ossification occurs for most bones? No, it's endochondral, from cartilage. Okay, but how do bones grow in width? Because if they just got longer, they would stay very thin, right, as you're growing. So that's called appositional growth. So what happens is osteoblasts build new bone. So the new bone is deposited on the outside, and osteoclasts kind of break down some of the inner surface, so the cavity in the center gets bigger, so it widens, the medullary cavity can hold more marrow. We will be talking about fractures, but kind of this relates because we're talking about building bone. So how do we repair fractures? Well, there are four main stages to fracture repair. First, there's a hematoma. So what happens, there's an injury, we have bleeding, a blood clot is going to close off those injured blood vessels. What's going to happen is osteocytes that depended on that blood flow are going to die, okay? Then the body is going to prepare to repair that bone. So some hyaline cartilage, or cartilage is going to be produced and laid down on the inside along the break and along the outside. So we got the inside and the outside, okay? That can be, if you have like a broken clavicle, that can be palpated. You can feel it. You can feel the bump where that soft callus is forming. And then we have the hard or bony callus. And so the osteoclasts, remember those are the cleaners, we don't want them here, we want the osteoblasts. They're going to come and replace that cartilage with spongy bone, okay? And you're definitely going to be able to feel a harder bump along the bone at this point. So the osteoblasts are building some new bone, and the bone is repaired, but it's not fully repaired because that's spongy bone, right? So our final stage is remodeling. So this can continue for months to well over a year. That compact bone is going to replace the spongy bone and make the bone stronger, okay? There may always be a slight bump. It depends how much remodeling is done. So let's look at all of those stages at once. So we have hematoma, blood clot, soft callus, that's laying down cartilage in along the break as well as along the outside. Then we have the hard or bony callus. So we're going to replace that cartilage with spongy bone, and we're going to have a bump. And then we're going to have remodeling, where we're going to kind of fine-tune the process and turn that spongy bone into compact bone. Okay. So which stage of fracture healing happens after the hematoma? That is the soft callus. All right, that's all of it in a nutshell.